up the windward side of the mountains, but on the other leeward side, the wind flows is control of the terrain and can be quite turbulent. So this is called the katabatic. This is like katabatic wind. The stronger the wind, the greater is the downward pressure, and downdraft is downward moving air. So this one can push down the aircraft. So we are going to see some flight safety. So for takeoff, the operator must have their accurate on-demand reporting of the wind speed and the directions at the runway and at the zone around the takeoff. We need to have information about the atmospheric pressure, the humidity, and visibility in the takeoff area. And we need the reporting of cloud cover and precipitation. Help them determine if conditions are favorable for safe takeoff. So we have to take care about all of these things. And in flight, so small UAVs often fly at lower altitudes, so they are directly affected by the weather. Because when we fly at very high altitudes, so you can see maybe 10,000 meters, so the weather condition in that height is very constant. It's almost constantly, so we don't have any effect to the aircraft. But for our small UAV, just on maybe 2,000 meters, so it will be affected by the wind, weather, the humidity, and everything. So we have to take care about the altitudes at UAV. And for land, the operators must must have accurate information on wind speed and direction. So this is similar to the takeoff. And they need this information in order to calculate the density altitude needed for land. So the hazardous weather conditions such as freezing rain and thunderstorm may be detrimental to the landing if pilots are misinformed. So the freezing rain and the thunderstorm. The freezing rain is very cold wind with very low temperature, and thunderstorm it means very strong wind, and it may make some very cyclone and back to the flight. So with the accurate weather reporting, the pilot can determine which approach can be used, and even in some cases where whether an approach should be attempted or an alternate landing base is required. So when he has some good information, he can predict the condition of land or flight appropriate with the current weather. So we have seen this one. So we are now see to see what is wind shear. Wind shear is a sudden drastic change in wind speed or direction over a relative small area. So for example, the flow of wind comes to an obstacle, and its speed and direction is suddenly changed. So it will make the wind shear. So the wind shear can occur at all altitudes, in all directions, and you can see that the wind shear can happen even when we have two layers of wind. They have the different pressure, temperatures, and it can change the direction of the wind also. So in all directions, and it's typically characterized by directional wind change. This at of 180 degrees, and speed change of 15 knots or more. So you can see 1 knot is about 1,852 kilometers per hour. So the low level wind shear can be particularly hazardous for remote pilots due to the proximity of the UV to the ground. The wind shear can cause violent updraft and downdraft, up or down, and due to increased wind speed, it can push the aircraft around horizontally with sudden, unpredicted force. So it can push up or push take off. It can push up and or push down the aircraft. So the wind shear is commonly associated with passing frontal system, thunderstorms, and temperature inversion with strong upper level wind. It has to be greater than 25 knots. So the microburst is a very hazardous effect. This is one type of wind shear. It is associated with convective precipitation, which is shorter and more intense. So maybe you have already know that the microburst is something at the ground. It's very small and it bigger. Microburst, and you can the wind speed around this one is very fast, and it can destroy everything in its way. So it's really dangerous when if our UV is in the microburst. So microbursts are often difficult to detect because they occur in relatively confined area of many airports. So many airports have wind shear alarm system to warn pilots. And wind shear is particularly important when flying in and around thunderstorm and frontal system. Microburst is sometimes it suddenly occur, and when we have some very strong difference between the pressure and temperature between the out and down, up and down, and they will create some. It's very complicated physical effect, and it will create the cycle of the winds. The surface weather maps provide information about fronts, areas of high and low pressure, and surface winds and pressures for each station. So this is some information about the weather, and the pilot has to read this one carefully in order to avoid some bad effect to the flight. So we have seen this is the isobar. Isobar is the curve that have the almost constant pressure. Yes, and the stability of the atmosphere correlates with its ability to resist vertical motion. A stable atmosphere makes vertical movement of air difficult. And you can see instability can lead to the turbulence, vertical clouds, and several surf or weather conditions. So you can see this is some isobar curve. So now we are going to see the adiabatic heating and cooling. So I think we should see the picture first. So here's the picture. Okay, this one is the adiabatic heating and cooling. So you can see at the low level of altitude. So the air, the volume of the air is small and the temperature is high. But the higher altitude, so you can see that the air is expands and cools. So this area is bigger and the temperature of the air is cooler. And in this one, so we have a very big, we have very big areas, and the temperature is decreasing. So you can see this one, the sinking air compresses and warms. Rising air expands the areas of the air and cools. So you can see when air rises, it expands and cools, and when decreases and when descends, it compresses and the temperature is increased. This temperature change will take place in on upward and downward moving air. Is known as the adiabatic cooling and cooling, and we have no transfer heat. Okay, so I will skip this one because we have seen the pictures. Okay. So we are now going to see the temperature inversion. So as air rises and expands in the atmosphere, the temperature increases. However, an atmospheric anomaly can occur called a temperature inversion, where the opposite happens. The temperature of the air increases with altitude to a certain point, called the top of inversion. Okay, we have this one. We will have the pictures of temperature inversion. So you can see in this picture is the normal condition. So the higher it is, the colder the air is. But in not normal condition, so you can see this layer is warmer than this layer, and the temperature inversion will occur between these two layers. You can see. So when the temperature inversion happens, the air also the pressure also changes, and we will have some kind of wind flows. Okay, so we have to take care about the moisture and the temperature. By nature, the atmosphere contains moisture in the form of water vapor. The amount of moisture present in the atmosphere is depends upon the temperature of the air. So every 10 degrees Celsius increase double the amount of moisture the air can hold. So you can see that for example, in some in summer where the temperature is higher, so the moisture is there, the air is higher, so we feel we feel it's better, and we have much more feeling bad, and we have I don't know how to say it, but we have a lot of water in our skin. Sweat. Yeah, I know. Sweat. Okay. So the only ways water vapor is added into atmosphere is through the evaporation and sublimation. So the evaporation is the process of change from the ice to the vapor, and sublimation is change from sublimation is change from
from ice to vapors without liquid state.
Yes, and the sublimation is
Sublimation.
so
No, it's okay.
okay.
From ice to
Evaporation.
liquid state.
Yeah, evaporation is the process of changing of liquid water to water vapor. Liquid evaporation. So when we have temperature, so yeah, and the sublimation is the changing of the ice, yes, to the air or to the vapor. So the relative humidity humidity refers to the amount of water vapor present in the atmosphere at a given time. So, in fact, the definition of humidity and moisture are sometimes they are, sometimes they may be the same. The humidity and the moisture, in fact, yeah. So the relative humidity is the actual amount of moisture in the air compared to the total amount of moisture the air could hold at that temperature. The dew point is the temperature at which the air cannot hold more moisture. So this is the maximum temperature. As moist, uneven air rises, clouds often form at the altitude where the temperature and dew point reaches the same value. So at this point, the clouds will be generated, and at this point, the air is completely saturated, and moisture begins to condense out of the air in the form of fog. So sometimes at the early of the morning we see some fog. It means that the dew point happens on the surface of the ground. So when this dew point occurs, so we will have some effect of the clouds, but the clouds on the surface of the ground we see that it is fog. So the planet can greatly affected by the cold. For example, the numb finger means that it's very bad to feel the finger, and because it's cold. Yes, the numb fingers can be very bad things when the feel of the control on the remote is so important. So with a numb thumb, one could easily bump the throttle down and not feel it. Batteries can also be really affected by the cold. So you can see the cold and the heart is not good for the flight. The air masses may stagnate in or move really slowly over an area with uniform temperature and moisture characteristics on day-to-day basis. The air mass takes on those temperature and moisture characteristics, mostly in places like polar regions, tropical oceans, and dry deserts. So these air masses is some kind of, for example, if this is some zone of the air, and this one may not move or disappear. So this is the air masses. And a front is the boundary layer between two different air masses. So, for example, we have two group of airs. So the front between them we call the front. It's a boundary layer between two different air masses or areas of pressure. So an approaching front of any types always means that where the changes are imminent. So when we have these two air masses along together, so they are different of the pressure, and the temperature will quit the wind. So the thunderstorms are produced by cumulonimbus clouds. They form when there is sufficient water, vapor, or moisture, an unstable lapse, a rate, and an initial upward boost to start the process. So generally, the most severe thunderstorm conditions are destructive winds, tornadoes, heavy hail. So this is the safety attention. So we do not operate an UAV within 20 nautical miles of a thunderstorm, since hail may fall from miles outside of the clouds. And any clouds connected to a surf thunderstorm cloud could spawn tornadic activity even if it is miles away from the main thunderstorm cloud. So the aircraft should not fly not far from the thunderstorm. The icing is bad also for the aircraft. So the airframe icing would be when ice builds upon the UV and it can no longer sustain flight, and aerodynamic qualities of the propellers change. So the worst condition is freezing rain. Freezing rain, I think, is some kind of rain with very small or big ice. Yeah. And the icing is really bad for it's really bad for the aircraft, passenger aircraft, because for example, for the big aircraft, we need to have a height tube in order to measure the speed of the wind with respect to the aircraft. And if the ice is on that tube, so the information from that height tube is or to the aircraft is not precise. So the pilot will misunderstand some information, and he cannot control precisely the aircraft. And it happened when the pilot is iced. So the aircraft is going down, and the pilot have no action on that, because he didn't have the good information for the speed. So the hail in a small hailstone can damage the UAV, the fog. So the fog will affect our vision to the drone. The ceiling and visibility. Current ceiling information is calculated by the temperature and the dew point, and is reported by the aviation routine weather report and automatic weather stations of various type. The visibility refers to the greatest horizontal distance at which prominent objects can be viewed with the eye. It can also be reported in meter, so this information we can get from the meter. So we are now going to see the effect of weather. The high wind can make it impossible to control our GPS or UV. A battery will drain fast, because the propeller has to rotate faster in windy conditions or flying into headwind. The higher wind speeds make it more difficult for the UV to hold its positioning, which will result in shorter flight time, less accurate position holds, and more difficult for maneuvering. So the key is to not fly in conditions where gusts may exceed the UV's top speed, not just the average wind speed. The bigger the UV, the stronger wind it will be able to take off in, and the pilot will understand its limitation. So the best way to fly in windy conditions is flying into direct wind. It means when the fuselage is parallel to the wind. Flying into the wind will allow maximum wind speed on leading edge of wing airfoil, as they are designed in such a way. But this isn't always possible as the path land may have orientation either away from or at an angle with respect to the wind direction with no choice. Okay, so this is the end for this slide. Okay, now we are going to the last slide. Yeah, the last lecture for the course. But I think we have already seen this one. But so I will skip if we have already seen it, some slides. So we are going to see something about the drone aerodynamics fundamentals. So the mass and the force, so I think everybody knows. The mass this is a property of body and motion of an object resistant to motion. It is constant and has the same value no matter where we are. And in the SI system, it's equivalent. And the force can be active or reactive. So, for example, we have the Earth gravity. The Earth gravity is pulled down on an object, and this force is called weight. So the velocity and the acceleration so the unit of velocity is meter per second, and the acceleration is the change of the. For example, when we push a force to the mass, so it will accelerate. So the velocity will increase. This acceleration is greater for a greater force or small or for a smaller mass. So the center of gravity is a point on the graph where there is different weight distributed on both sides. I think this is everyone has known. Okay, so we have seen we have so the center of gravity, how to calculate it, and we have to calculate the center of each part and the weight, so we can calculate the equation of the center of gravity with respect to the whole graph. The basic expression of a graph, I think we have seen yesterday. And you can see we have many graphs to the airplane. We have the graph of the wing, on the tail, on the fuselage, and on the engine. So, and the Newton's law of motion. So we have three laws: 1, 2, 3. So okay. So this is the torque and coupling force. So this is this one. So these two forces will create the rotation about this axis. So the aerodynamics is a study of forces and the resulting motion of object through the air. The aerodynamics affects the motion of airplanes, helicopters, airships, rockets, and drones. The motion of an aircraft through the air can be explained and described by physical principle. And we can write some mathematical equation in order to express the motion of the aircraft. So this is the action force and reaction force to the plane. So fluid dynamics involves the interactions between an object and a surrounding fluid, liquid or gas. Fluid dynamics play a major role in the development of thrust in a gas turbine engine and in the generation of aerodynamics, the rock for flight within the atmosphere. So you can see that whenever, because for example, when we push something in the air, it will be easier when we push something on the water because the concentration of the water is much higher than the air. So the drag inside in the water is much higher the graph on the air. So this is the this is how the airflow flows through the wings of the aircraft. This is the airflow through the turbine of the aircraft. I think we have seen the visual is there, right? No? Yes, I think we so we can see the airflow when we rotate the propellers. This is just the simulations, not the ground, but yeah. So yeah, this show you. So the definition of the atmosphere we have seen yesterday. This one, the viscosity and the viscosity of water and air, bodily layer, compressivity. This is the speed of cell in different altitudes. So the atmosphere, yeah, got several layers. So the aerodynamic forces directly depends on the air density. To have aircraft designers, this is useful to define a standard atmosphere model of the variation of properties through the atmosphere. And this model is changing, and we have to see day by day and in sub predefined weather conditions. Standard atmosphere. So for the aircraft we have three translation motion. We have longitudinal motion. This is the x-axis. The lateral translation. This is the y, and this is the vertical translation. This is the z-axis. And we have three rotations. This is wrong. This is with respect to the about the x-axis, which about the y, and z about the z-axis. And this is the forces acted to the aircraft. We have the thrust, we have the drag, lift, and the weight, and this is the center of gravity, and this is the center of pressure. So I think this is what we have already seen in the meters telescope. Okay. Because we have almost seen everything. Just some definition of the force, the motion, the relation, and the relationship. I think it's better for you to read on the slide. Right? You want me to read or you think so? Okay, so I think it's better for, because this one is very video knowledge, so everyone knows. Okay, so I will stop here, and we can start for the practical work.
Just moment, I see that the operation is going, so we want to have a 10-minute discussion for children, for school children, if it's possible. So they are doing the work.
Okay.
If we finished with the lecture, пришли школьники, 10 минут назад сделали большую экскурсию на рассказ. Нет, сейчас я не знаю, просто мы как раз совпало, что мне позвонили, переключили, и мы закончили лекцию.
Yes, I think this is some safety line. Yeah, this yeah.
Рисунки, когда показывают, где топливо, где что, это все.
Бывает, что когда дополнительно открыли, ставят еще в основном части от крылья.
То есть там, где пилот, там очень много посередине пилот.
Да, я такого лично я не встречал жалобы. То есть всегда это крылья, и плюс где-то еще. Когда это очень важно, было много происшествий, когда, например, самолет летит, у него груз, и очень плохо зацеплен. И резко в полете съезжал назад, и меня совершенно кажется, что падал, реально катастрофа, даже просто
Если топливо должно быть сюда, да?
То есть они берут куда-то возмутительные пожаров, они же набираются водой. Это еще учитывается. Это, что вы говорите, часть. Это
они могут по этим баллам
есть, в принципе, конечно, есть и набираемый запас.
Это такое условие для самолета, чтобы он не сел,
Ну, то есть, когда рассчитывается количество топлива, которое надо, рассчитывается история людей, плюс еще 50 на случай, если я такая погода мне придется обслуживаться, и плюс еще столбик, который, как бы, он в этом полете. Ну, вот так как там и что, что топливо было под я такого не слышал, может где-то
Если можно.
Что